Dear students, in the today's lecture, myself Rakhi Kumari, Assistant Professor in the Department of Electronics and Communication Engineering, ABES Engineering College, going to start with linear and non-linear system, which comes under the category of types of systems. Dear students, whenever we talk about the linear and non-linear system, what is the basic thing here is that the linear system has to obey the principle of homogeneity and superposition. So, before going towards the deal in the linear system, we have to first discuss what is meant by the homogeneity and what is meant by the superposition. So, let's take a system. Let it be a system. And whenever we provide the input to it, in the return, we are getting the output. So, if the given system is linear, so when we provide the x1 as the input, we are getting y1 as the output. And when we provide x2 as the input, we will get y2 as the output. And if the system follows the principle of superposition, it means when we provide the input of x3, which is actually the summation of x1 and x2, we will get the output y3, which will be the summation of y1 plus y2, which we get as the output when x1 is given as the input individually and x2 is given as the input individually respectively. So if this condition is satisfied, then the system is said to follow superposition theorem. So now comes the condition for homogeneity. So when we talk about the homogeneity, in that case, if we take the same system and if we provide x1 as the input and we are getting y1 as the output. So in that case, if we multiply any constant a with the input, the output will also get multiplied with the same one. So we can say that the system follows the principle of homogeneity. So for the system to be a linear one, the system has to follow both the homogeneity and the superposition principle. So for getting the equation for the linear system, we have to combine the homogeneity and superposition. Now, in that case, our system of equation turns out to be ax1. If we are talking about the continuous time, then the t under bracket should be included plus bx2. It passes through any system which is represented by t. So at the output, we are getting ay1t plus by2, or in other terms, we can say t, that is the system, is provided with the input of and So this is called the condition of linearity. Because here we can say that principle of homogeneity for both the input are given, and when we insert the plus sign, we are actually implying the superposition principle. So this particular equation follows the both the condition of homogeneity and the superposition. So this is said to be the condition of linearity, or the same condition is applicable for the discrete time system also. But in that case, x1t get replaced by with x1n. Otherwise, the condition remains the same. So let's try to do some numericals related to the linearity of a system and check whether the given system is linear or not. So this is the first numerical which we are going to discuss. In this one, you have to test the linearity of a system which is provided by this given equation. You have to check whether the given system is linear or non-linear. So what will be the steps to solve this? You have to first say, as already explained to you during the explanation part, x1t is giving the y1t as the output. So if y1t is the output when x1t is the input, in that case, the above equation changes into t dot x1t, because at the place of xt, we are taking x1t as the input. Similarly, when we are giving the x2t as the input, we are getting y2t as the output. So if y2t is the output here, x2t will be the input. So the given system equation changes to t dot x2. Now, let that we are providing x3t as the input, which is actually ax1t plus bx2t. All of you should be aware that we are taking this thing a and b multiplied because we have to maintain the homogeneity of a system. You can also, so we are adding a and b respectively to the input x1 and x2, and then it is added to give the y3 as the output. So when we are providing this as the input, in that case, of course, we are assuming that when we are providing x3t as the input, we have to receive y3t as the output. And what will be this y3? It will be, of course, t dot x3t. And what we are considering x3t here? x3t is equal to ax1t plus bx2t. So x3t should be replaced with ax1t plus bx2. So what the output we are getting? T dot a x1t plus b dot t x2. And now, when we look at this will be exactly like this: a t x1t plus b t x2t. And if you properly see this two terms, t x1t plus and this one t x2t, what we are getting? This is actually y1t and the y2t. So at the place of that, we can write a y1t plus b y2t. So what we are getting? When we are providing this as an input, that is ax1t plus bx2t as the input, what the output we are getting? A y1t plus b y2t. And this is the condition of linearity. As per that, if we are giving x a x1t plus b x2t as the input, we have to receive a y1t plus b by 2t as the output. This means that the given system follows the condition of linearity. So the given system is linear here. So in this way, we have to check whether the given system is linear or non-linear. Now let's move to another numerical for the better understanding of the system. Now let's do another numerical, that is question 2. So again, in this system also, we have to check whether the given system is linear or not. So again, we are assuming that we are giving x1t as the input to the system. In that case, we are getting y1t as the output. And y1t will be equal to x in 1 square upon and within bracket t. And when we provide x2t as the input, we will get y2t as the output. And this will be equal to x2t square. And in this given system, if we multiply a and with the b here, what will happen? A here and the b here also get multiplied, and the system, in the system also. Now we are taking x3t as the input, and that x3t should be equal to this one. In that case, when we are taking y3t as the output, what will be this y3? 3. This will be x3 square t. That means we have to take ax1 t plus bx2 t whole square. That means this will be a square x1 square t plus b square x2 square t plus 2ab x1t x2. But here comes the difference. If we are, let's take a y3t dash as the output for a y1t plus b y2t. In that case, it is equal to a x1 square t plus bx2 square t. For the homogeneity condition, already we have checked. If we are providing this as the input, within bracket we have to take t when we talk about the continuous one, we will get a y1 t plus b y2t as the output. And this a y1t and b y2t is the individual output when we are providing a x1t as the input and b x2t as the input. So already we have got it. That is when we provide the ax1t individual as the input, we are getting ay1 as the output, and this is equal to ax1 square t, which we have substituted here. And when we provide bx2 individually as the input, we are getting ay2t as the output, and this is equal to bx2 square t. So we have written here. And so we can say that for a system to be linear, this y3t and this y3t dash has to be same. But what is happening here? In this particular system, this is not. We can say that for the system to be linear, this y3t and y3 dash has to be same, but this is not actually happening. So the given system is not the following the condition of what? Superposition and homogeneity. So the given system is not linear. Basically, it is non-linear. These are the references which we actually used for getting this lecture ready. This is the disclaimer regarding this lecture. Thank you for listening this lecture.